Hello class, welcome back to the week 12 material, and in this segment we're going to look at how we can apply colors to our web page, including changing the color of text and changing the background color of our web page if we want to do that. So that's what we're going to cover in this segment. So in order to make use of this, we first have to get back onto the server and go into our HTML file that we created earlier. And now that we're on the server, we'll go find our HTML file. And this will bring up what we left off with last time. And here you can see this is what we had last time. So I'm going to go ahead and change a few things that we had here so that this is a little bit more readable as to what's on the screen here. So let me actually go ahead and get rid of this as well. I'm going to focus mainly on what's between the two font tags here, and I'm also going to get rid of the size. So I'm going to focus on a new attribute that we can put inside the font tag. So one attribute that we looked at in the previous segment was the face attribute, which changes the font itself, the size attribute, which changes the size of the font. Now we're going to look at the color attribute, which allows us to change the color of the font itself. And there's a couple different values you can put into the color attribute. The first one we're going to look at is much more straightforward, but kind of restrictive. And the second one we'll look at is a little bit more complicated, but it works for anything at all. So the first one that we're going to look at is color equals a plain English descriptor. And the way that the browser is going to interpret this when you load up this web page is it's going to find this color tag. It's going to find this plain English descriptor, and it will find a color to match that plain English descriptor and then apply that color to whatever is contained within the font tags here. So if we want to see what this looks like, first we have to save it to find out what it looks like. There we go. And then we go to the URL to view it. And you can see this text now is in fact red. And I can change this to some other plain English descriptor like blue. Again, make sure that's all in quotation marks to make sure it's reliably read or reliably interpreted by the browser. And you can see it does in fact become blue. Now, you can put anything in here technically for the color, but if you put in really obscure colors like periwinkle blue or something to that effect, then it might not be recognized the way you want it to. So if you put in a color here, a plain English descriptor that is not recognized by the browser is going to take its best guess as to what that color is supposed to be, and then apply that color to whatever is contained within the font tag. So if you try to put something in here that's really obscure or something that's not recognized by the browser, then the browser may not display it the way you want it to. So that might then raise the question, how do I get any color at all to be applied to the text that we're working with? And to do this, we first have to think about a couple things. First of all, you may have remembered this from your physics classes, but all colors of light can be decomposed into red, green, and blue components. And it also turns out that the pixels on your computer screen have 3 little subpixels. And each of those subpixels basically has a very, very tiny, almost microscopic red, green, and blue light in each pixel on your screen. So if you can imagine a screen that has 4 or 8 million pixels on it, that'd be a really large television screen. Each one of those pixels has 3 different lights in it that has a red light, a green light, and a blue light. And we can get any color we want by giving it different values of red, green, and blue. And those values that we give it are the intensity. So if we give the maximum value for red, that means the red crystal in the pixel is going to be on its highest value. It's going to be as bright as it can possibly be. And if we say no green and no blue, then that would just give us a pure red pixel. And you may have also heard of something called a red, green, blue, or RGB triplet, and that's where that comes from. You give the computer a certain value you want for each red subpixel, green subpixel, and blue subpixel, and that then translates into a color that our eyes just blend those components of red, green, and blue together into any arbitrary color. And the values that you give the color value in the font tag, that gets a little bit interesting, and there is sort of a way you can make this work that's a little bit simpler, but from my experience, it's not especially reliable because, and that's especially the case for the modern day browsers. But to understand what exactly is going on here, we have to first introduce the idea of hexadecimal, which is a numbering system that is in base 16. So go ahead and choose sort of what that looks like. So in our everyday life, we're used to working with a base 10 numbering system where the maximum value of a digit is 9, and the counting for that goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then all the way out to whatever. In base 16, the maximum value that a digit can hold is 15, which we normally think of as a 2-digit number. So it seems kind of weird to have a digit holding on to something that's normally a 2-digit number. So to sort of represent that, we use lowercase letters. So the counting for hexadecimal, it looks very similar to begin with, very similar to base 10 to begin with, but it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go to a lowercase a because remember the maximum value a digit can hold on to is 15. So we don't carry anything over into the ones place just yet. And instead we use a lowercase a to sort of represent this particular digit has a value of 10 in it. And then the lowercase b represents a value of 11. C represents a value of 12 in a digit. D a value of 13 in the digit. E a value of 14 in the digit. And then F a value of 15 in digit. And now that adding 1 to this digit gives us the maximum value, or goes over the maximum value, then we carry the 1 over. So now we go to a 1 in the 16s place, what we would normally call the 10s place, and then a 0 in the 1s place. And then the counting kind of proceeds from there. So it goes 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. And then again, we go to a lowercase a, 1a, 1b, 1c, 1d, and then so on and so forth. And then at some point you'll get up to, if you keep counting, you'll get to a point that looks like this. So you get 9, 8, 9, 9, 9a, 9b, 9c, 9d, 9e, 9f. And then when we go up to the next value, we carry the 1 over. Remember, the maximum value a digit can hold is in fact 15. So instead of going from 9f to 100, we in fact go from 9f to a0 because adding 1 to a digit of 9 gives us a lowercase a, so the counting would then proceed as A0, A1, A2, A3, A4, and then so on and so forth. And then the maximum value you can store in a 2-digit hexadecimal number is in fact FF, which if you translate that into base 10, that is in fact the number 255. And when you're working with an RGB triplet, the highest value that you can put in for the red, green, and blue values is 255. So the highest value you can put in for red is 255. The lowest value you can put in is 0. Same thing for the green, 0 to 255. And then same thing for the blue component, 0 to 255. Some integer between 0 and 255. So that's sort of a look at hexadecimal. So one thing that you can sort of think of is for each digit in a hexadecimal value, you can sort of think of it as the highest value you can put in is anywhere from 0 to F. So if you just think about this right here, just the basic counting system, just keep in mind that each digit in a hexadecimal number has to be something like this, and this is how the counting system works.